So first thing we're going to look at today, I'm going to break it into like small little chunks here. Is we're going to convert fractions to decimals without a calculator. All right. So if I have, so actually, before we start, which way is the decimal going to, let me just write this. E5 over 10. Okay. What does that say? 85 over 10 or 85 tenths, right? If you have it in the denominator, we say tenths or hundredths or whatever, okay? And then we did the place value stuff the other day. Tenths is the first decimal to the right, okay? So if I want to convert this, does anybody know what the answer is? It's 8.5. The decimal on the 85 is right there, correct? When we're converting to decimals, we move the decimal point to the left. All right. So all you really need to do is look at the denominator, the bottom number of the fraction. It is 1 over from the 0. So I move the decimal 1 point to the left. So this becomes 8.5. That decimal just moves there. That's it. 85 divided by 10, if you put it in your calculator, you'll get 8.5. So the decimal point okay, next one. What if we have 85 over 100? So we'd say 85 hundredths. Where is a hundredth on the, what do you call this? Place value line. It's right beside the tenths, right? That would be the hundredths. So it's 2 points to the left, which means you move the decimal 2 points to the right. So what do we get? If the decimal's there, where's it going? 1, 2. So the answer is, that's all you're doing. You just look at the denominator, the bottom number, whatever it is, if it's tens, hundreds, if it was thousands, how many spots are you moving the decimal? You're moving it 3 because thousands is 1, 2, 3 from 0, right? We move it 3 spots. Is that okay? All I want you to do is page 11, please. Page 11. We just went from fractions to decimals. The decimal point moved left. If we're going to go the other way, we're going to take a decimal and convert it to a fraction. Which way is the decimal point going to go? Right, exactly. Okay, well, that says right. Spelled weird. Okay, so let's start with 0.35. Are you allowed to have decimals in a fraction? Can I write this? I mean, you can, but nobody would, right? We don't, that's, yeah, don't do that. So we need to get rid of this. We want whole numbers only. So I take my decimal and I move it 2 spots. That gives me 35. If you move it 2 spots, what number do I have to put in the denominator? So let's look at our number line. I moved it 2 spots. Anybody guess what number I'm putting in the denominator? We're doing hundreds in the denominator, right? Tens, hundreds. Okay, that's 2 decimal spots. So all I do is throw 100 in there. $35 divided by 100 is 0.35. Now, am I done? Why am I not done? You always lower it to, what is going on out there? Always put your fractions in lowest terms. So we did this last week, right? How do you convert something to lowest terms?
Divide
By what?
by whatever will fit.
Whatever will fit in both, right? So what number will go in 35 and 100?
5.
5. So I divide top and bottom by 5. Divide by 5. Divide by 5. 35 divided by 5 is? 100 divided by 5 is? 20. So that's the answer. 720. 7 over 20. All right, so let's try this one more time. If I have 1.3, how many places do I have to move the decimal? To get a whole number, I guess, is what I'm saying. 1. So I'm going to move it 1 spot to there. That gives me 13. If I move it 1 spot, what is that on the number line? That's a tenth, right? There's 1 spot. So it's a tenth. So you just put 10 in the denominator. Then ask yourself, can you reduce it?
No.
No. So you're done. What if you have some ugly number like this? $2.3567. How many decimal places do I have to move the decimal to get it so we have a whole number? So I'm moving up 4 spots. 1, 2, 3, 4. So in the numerator, decimal's gone. Over what number? 10,000. If you look at your number line, tenths, hundredths, thousands, there's 3. One more would be 10,000. So I just put 10,000 in there. Okay? So however many decimal points you move the decimal, that's essentially what your denominator is. And then always, always, always reduce. Okay? Page 12, please. The next page. What does percent mean? Sorry? Out of 100 means per 100. That's all it means. Okay, so per 100. So if I have, so we're going to go through a couple of different things. We're going to convert a percent to a fraction. So if I say 72%, what is that as a fraction?
72 over 100.
That's all you do. You take the percentage, you just divide it by 100. So that's what percent means. Now, you have a fraction. What do you always have to do with your fractions? Put them in lowest terms. What goes into 72 and 100? 2. What's 72 divided by 2? Ooh. 36. You have a calculator in your hand? So you just lied to me?
I swear on everything. Every pair of shoes I own, I do not lie.
So 36 out of 50? Can I keep going?
Yes.
It's not lowest terms. What goes into 36 and 50? 2. What's 36 divided by 2?
18.
Okay, am I done now?
No. Wait, no. He is stupid.
You are done. 5 does not go into 18. Okay, so 18 out of 25. So we could have divided? We could have divided by what number right at the beginning to get that? 4. All right, so if you use a bigger number, you get there faster, but it doesn't matter in the end. Okay, so 18 out of 25. So all you do, if you're given a percentage, just divide it by 100, whatever that number is, and the percent goes away. Oh, what am I? I just gave you the answer. Pretend I didn't write that. 150%. What do I write? What do I write? 150 over 100, right? Doesn't matter if it's over 100%. You just write 150 over 100. Now, what do I do to simplify this? What's a quick step if you have zeros on top and bottom? 10, but also you can do this. Dividing by 10 is the same as just knocking off zeros, right? Have you seen that before? If you have a 0 above and below, essentially you can just knock them off. That's the same as dividing by 10. So this would be 15 over 10. 5 goes into both of those, right? Which gives me 3 over 2. Okay, that's percent to fraction. What about number 3 or 2? B. I think it's B that we're on. What if we do percent to a decimal? We've already technically done this. So we'll use the same numbers. 72%. There's a couple ways to do this. The long way, is, well, 72% is 72 over 100, right? Write it as a fraction. And then you use what we just learned up here, or reviewed up here. If you're going to convert a fraction to a decimal, this number tells you how many decimal places to move it. So since it's 100, this becomes, and the decimal's there, I move it 2 decimal places. So 0.72. What's the straightforward, fast way to do it? Just move it. Yeah, just move it 2 decimal spots. So if you're here, you can move the decimal 2 places over. So if I have 36.4%, what does 36.4% become as a decimal? Just move the decimal 2 spots. 1, 2. 0.364. Okay. Now a fraction to a percentage. So the straightforward one is if we have the fraction out of 100, right? Because that's essentially the definition of a percentage, right? Per 100. So if I have 36 out of 100, what's your percentage? It's 36%. But what if it's not out of 100? So let's say 12 out of 10. I don't know how you get 12 out of 10, but maybe you get the bonus. Okay? 12 out of 10. How do I write that as a percentage? Now, it's not out of 100. So you can make it out of 100. What do I need to multiply 10 by to get to 100?
10.
So if you multiply by 10, and remember, you've learned what you do to the bottom, you have to do the numerator, or what you do to one side, you have to do the other side if you're doing algebra. So it's the same thing here. If I multiply the bottom by 10, I multiply the top by 10. So what's 12 times 10? 120. And 10 times 10 is 100. So we have 120 out of 100, which is what in percentage? 120%. So if it's not out of 100, you can quickly just multiply by whatever number top and bottom to make it out of 100. And that gives you your percentage. So what about 1/5? Not out of 100. What do I multiply 5 by to get 100? 50, 20. So if I multiply this by 20, multiply that by 20, and that gives me 20 out of 100, which is 20%. All right. Last one. The decimal to a percentage. .36. Does anybody just know how to do this? How do you convert any decimal to a percentage? You move the decimal, or you
just move the decimal to the right.
Yeah, you move the decimal to the right, 2 spots. Or, so essentially, here, 1, 2. It's 36%. The other way to do it is just multiply by 100. That's it, which is essentially moving the decimal 2 places. So multiply by 100, move decimal 2 places right. So 0.475. That's it. So you can either just move the decimal 1, 2 spots there, and I get 47.5%, or times by 100, which gives you the exact same thing. Multiplying by 100 is moving the decimal 2 spots to the right. How's that? You've done this before? Perfect. Page 13. Please. And then we're on to one-step algebra equations. Everybody likes algebra. First thing is we have to know what the opposite operations are. So if you're doing addition, what's the opposite of addition? Subtraction. What's the opposite of subtraction?
Addition.
The opposite of division? And then multiplication is division. Okay. What is you've probably heard this, I think, I would hope so. Essentially, the number one rule when you're doing for algebra. It applies to all math, all the way up through calculus and whatnot. Do you know any rules for algebra? Sorry? That's it. What you do to one side of the equation, you must do to the other. And that goes all the way up. So, right, that applies to everything. It's not, these are just some operations. There's other things as you go up through math, square roots, cubing, logging both sides. That's a math 12 thing. Whatever you do to one side, you do to the other side. The second one's not really a rule, but sort of a guideline. I don't know what it is, but I'm going to write it down here anyway. To remove a term, in this case, they're going to be a number. If I put a hashtag or a pound sign, that's my shorthand for number because I'm too lazy to write the word number. Okay. That means number. That's what you'll see that a lot in this course. To remove a term number or term, do the opposite operation. Okay. All right. So what you do to one side, you have to do the other side. So for A here, you need to isolate the variable, right? What's the variable? If I say the word variable, what am I talking about?
The X.
The letter, essentially. But yeah, in this case, the X. Okay. So how do I get rid of the positive 5? Subtract, because it's being added, right? It's X plus 5. So if I want the 5 to go away, do the opposite operation, which is subtraction. So I subtract 5. What you do to one side, you have to do to the other side. So the X is still there. 5 minus 5 is 0. No 5s. What's 22 minus 5? That's your answer. What should you do? I don't know if they taught you this last year. It becomes more important when you get into more complex equations. What should you do once you have an answer? Check it. So you put it back in, right, to make sure you got the correct answer. So the check, or verification, some people call it, is to put 17 in for X. So I get 17 plus 5. 17 plus 5 is? So you get 22 is equal to 22, and you know you did it right. This becomes a lot more important when the questions get more complex. All right, B. X minus 6 is equal to negative 4. I need x by itself. How do I get rid of the negative 6? You add it, right? You add positive 6 to both sides. So plus 6, plus 6. Negative 6 and positive 6 is no more 6's. What's negative 4 plus 6? Positive 2, right? That's the integer stuff we did last week. All right, C. X is on the other side. Doesn't matter. So you need the variable or the x by itself. So I need to get rid of this minus 10. How do I get rid of the minus 10? You add 10 to both sides. What's negative 6 plus 10? Negative 6 plus 10? Peoples?
4.
Positive 4. And always check your answer. So I know I didn't check B, but we'll check C. So I put positive 4 in for x. So I get negative 6 is equal to 4 minus 10. 4 minus 10 is negative 6. So you know you did it right. As long as they equal, you're fine. All right? Is that okay? All right. That's addition and subtraction. We'll be on D. What about something like this? X over 2 is equal to 22. So, what does the line mean? What operation is this? It means divide. X divided by 2, some number divided by 2 is equal to 22. So if we're dividing, what's the opposite operation of dividing? Multiplication. So, what do you multiply by? If I need to get rid of the 2 or in the denominator, you multiply both sides by 2. Okay? So this side gets multiplied by 2, and this side gets multiplied by 2. What you do to one side, you have to do to the other side. Now I'm going to write it out in the proper math way, but you can just do a short, I don't want to say a shortcut, but you'll see. You can just cancel this right away. So if I multiply this by 2, I end up with 2x over 2 is equal to 44. Does everybody agree with that? What happens to these 2's right here? They cancel each other out. So you're just left with x is equal to 44. And I know you can do a lot of these in your head, but they're going to get more complex where you can't, and you have to follow these rules. And the better you get at laying out the steps, you will not get confused, hopefully, when we do the more complex ones later on. What should I always do? Check. So we'll just do a quick one. Put it in for x, 44 over 2. 44 divided by 2 is 22, so you know you did it right. All right, one more, and then you have practice, and then we're done. E. 3x is equal to negative 21. So if I write a number beside a variable, what operation am I doing here? What does this mean? That's multiplication, right? 3 times some number x equals negative 21. So what's the opposite of multiplication? Division. So I divide both sides by 3. You could write, I guess we can do it another way. You could do this. I don't know how I'd write this. Divide by 3. Divide by 3. You could write it that way. Most people, as you move up, would write it this way because this means division. Okay? So then those 3's cancel. Because 3 divided by 3 is 1. And what's negative 21 divided by 3? Negative 7. So that's the division and multiplication of integers that we did last week. Is that okay? All right. Page 14. It's the last, page 14 and 15, I guess. It's the last little bit.